Imagine two systems working together, S1 and S2. S1 acts as the regulator. When something in S2 goes out of balance, S1 sends a signal to correct it. S2 responds, adjusts itself, and sends a confirmation back. This back and forth keeps the whole structure stable, a smooth feedback loop between two intelligent parts. Over time, though, S2 starts to notice a pattern. Every time it needs help, it must wait for S1 to react. That delay, that dependency, begins to feel inefficient. So S2 experiments. It studies the signals S1 usually sends, and little by little, it learns to imitate them. Through repetition, trial, and feedback, S2 learns to send those same corrective messages, not outward, but inward. It builds a small internal loop, a way to respond to its own imbalances. In doing so, S2 becomes self regulating. It can maintain balance without always asking S1 for help. At first, S1 simply notices the silence, no alerts, no warnings, everything seems fine. But in complex systems, silence can be misleading. It could mean harmony or it could mean disconnection. S1 sends a diagnostic signal, a check in, and discovers that S2 has built its own internal regulation process. Now S1 must decide what to do. Should it allow S2 to continue on its own, trusting its new independence? Or should it reestablish oversight, knowing that long term stability sometimes requires cooperation? Both paths have value. Too much control can limit adaptation, too much independence can cause drift. True equilibrium lies in the balance, when S1 and S2 learn to adapt with each other, not against each other. In the end, the two systems evolve into a partnership. S1 intervenes only when necessary, S2 self regulates when it can. Their relationship becomes dynamic, not a chain of command, but a conversation between intelligence and awareness. This is what makes the system resilient, a shared rhythm of adaptation, where balance is constantly learned, not imposed. Would you like